Let's go to guided practice 2. Lorado is concerned about the average waiting time for patients to see a nurse. The health center aims for at least 95% of patients to see a nurse in under 20 minutes. Lorado assumes that the waiting times for patients are independent of each other and decides to perform a hypothesis test at a 10% significance level to determine whether the health center is meeting its target. Lorado surveys 150 patients and found that 11 of them waited more than 20 minutes. Performed the test, clearly stating the conclusion in context. This is a binomial test for proportion P. The test is to determine whether the health center is meeting its target. The target is that at least 95% of patients to see a nurse in under 20 minutes. The observed frequency is that among 150 patients, 11 of them waited more than 20 minutes. 150 minus 11 equals 139 patients waited under 20 minutes. So HO P equals 0.95. H1 139 over 150 equals 0.927 less than 0.95. So P less than 0.95 for H1. Second step, let's define the variable. Let X be the number of patients in under 20 minutes. Then X follows binomial distribution with 150 as the sample size and 0.95 as the probability of success. X statistic equals 150 minus 11 equals 139. E of X equals 150 times 0.95 equals 142.5. Let's draw the diagram. This is 142.5. X is 139. Based on the definition of p-value, this is a p-value. P-value is the probability of obtaining the observed result when HO is true. So p-value equals probability of X less than or equal to 139. Let's go to binom CDF. Menu 6, 5. B binom CDF. N is 150. P is 0.95. Lower bound is 0. Upper bound is 139. Enter. Answer is 0.132. Let's draw the conclusion. Since p-value 0.132, let's check the significance level. 0.1, greater than 0.1. Fail to reject it all. Let's check which one is the claim. This is the claim. Fail to reject it all. This is a check. So we can write down the conclusion like this. Enough evidence to suggest that the health center is meeting its target. Guided practice 3. The principal of a school is concerned that only 30% of her students are choosing healthy options from the school canteen. She organizes a campaign to promote healthy eating and decides to test if the campaign has increased the number of students choosing healthy options at a 5% significance level. She assumes that a student's choice is independent of other students' choices. The principal takes a random sample of 80 students, and 31 students choose a healthy option. State the conclusion of the test. Give a reason for your answer. This is a binomial test. The students have only 2 choices: choosing healthy options or not choosing healthy options. So the number of students who are choosing healthy options will follow binomial distribution. HO, P equals 0.30. H1, P greater than 0.30. Because we want to test if the campaign has increased the number of students choosing healthy options. Second step, define the variable. Let X be the number of students choosing healthy options. Then X follows binomial distribution with 80 as a sample size and 0.30 as a probability of success. X statistic equals observed frequency 31. E of X equals 80 times 0.30 equals 24. Let's sketch the diagram. This is the mean, 24. This is X equals 31. Based on the definition of p-value, we know this area is a p-value. Therefore, p-value equals probability of X greater than or equal to 31. Let's go to binomial CDF. Answer is 0.0587. Let's draw the conclusion. Alpha is 0.05. Since 0.0587 greater than 0.05, fail to reject HO. Let's check which one is the claim. We want to test if the campaign increases the number of students. So this is the claim. Fail to reject HO. This is a check. This is a cross. So we can draw the conclusion. Not enough evidence to suggest that the campaign has increased the number of the students choosing healthy options.